Students, in this video, we will have a look into the correlation between time and frequency domain specifications. Of course, by looking at the expressions of time domain specifications and frequency domain specifications, you can see or you can say what is the correlation. But still, we are giving here a few graphs which will better tell you what is the correlation between them. Okay, so here this is these are two graphs. One is magnitude of closed loop transfer function varying with respect to frequency. Another one is phase of closed loop transfer function varying with respect to frequency. So this is for a second order system. The closed loop transfer in the previous video we have seen we have converted the closed loop transfer function into a magnitude part and phase part, that is the m and alpha. We have two different expressions, and now those two expressions we are showing it in graphical format such that it varies with respect to u, that is the frequency. So here if you look at these graphs, this graph is, that is m is varying with respect to u for tau greater than 0.707, and this graph is for tau less than 0.707. See, when tau is greater, you can see that the resonant peak value is coming down. Okay, when damping ratio is lesser, that resonant peak value is getting higher. Okay, so you can see that relationship here, and this is a phase varying with respect to u. As the frequency increases, you can see that the phase value also goes down. Okay. And this is a relationship between bandwidth frequency and tau. Okay, so here the bandwidth frequency is a frequency domain spec, and the tau is a time domain specification. The main time domain specifications are all were depending upon tau and omega d, isn't it? So here now we are showing a relationship between tau and bandwidth frequency. Okay, normalized bandwidth frequency. So how that particular bandwidth frequency varies with respect to tau. Okay, bandwidth is higher when tau is lesser. Okay, bandwidth is shorter or low when tau is higher. Okay. Here you can see two graphs, one is MR and another one is MP. This is resonant peak, that the MR that we have seen in frequency domain specification. This MP, if you remember properly, it is from time domain specification. Okay, peak value. In time domain specifications, we have derived this MP. Okay, so just showing how this MR and MP varies with respect to tau. Okay, MR and MP varies with respect to tau. Just go back and see the expression for MR and MP. This is a time domain specification MP, and this is a frequency domain specification resonant peak MR. Okay, this is peak overshoot. Okay, peak overshoot, which happens at the time peak time. Okay, if you remember it from the second unit that we have done. Okay, so those two, of course, are dependent on tau, how that varies with respect to tau. Okay, and this is another graph showing the relationship between or the omega r by omega d with respect to tau. Okay, omega r by omega d with respect to tau. So just these are few graphs to tell how these specifications varies with respect to tau and frequency. Okay. In the next video or in the next class, we will be seeing a very interesting topic like how to draw frequency response curves for the given transfer function. Okay. First thing we will do is we will draw the frequency response curves using Bode plot. Okay. So that will be dealt in the next video.